In this video, you will learn how to determine the alkalinity and constituents of given water sample. We will be following 4 steps, and these are: Number 1. Take 20 ml of sample solution in conical flask and add 2-3 drops of phenolphthalein indicator. 2. Titrate this against HCl solution until the solution becomes colorless, and note the readings. 3. Add 2-3 drops of methyl orange indicator into the flask and titrate it again. 4. Stop when you see red color and note down the reading. That's it. We'll need alkaline water sample, beaker, funnel, N/10 HCl, conical flask, measuring cylinder, phenolphthalein and methyl orange indicators. Put the funnel on the burette's head and fill it up to 0 marking with N/10 HCl. Remove the funnel and put the HCl container back to the rack. Now measure 20 ml of alkaline water sample and pour it into the conical flask. Add 2-3 drops of phenolphthalein indicator. This gives pink color to the solution. Now put the flask below the burette and open the stopcock, so as the HCl flows in drop by drop. Continuously shake the flask during this process to let the drops mix with the solution completely. Titrate until the pink color vanishes. Depending upon the alkalinity of the sample, the time taken to vanish the color varies. For example, it can happen in 25 to 50 seconds or can take 1 to 3 minutes. We can see the color is disappearing slowly, so be careful and stop the titration as soon as it dissolves or disappears completely. But wait, what is this all about? What's happening here? Let's see. The alkalinity of water is due to the presence of one or more of the following salts. And these are the hydroxides, carbonates and bicarbonates of sodium, potassium, calcium and magnesium. When HCl comes in the solution, its H plus ions react with the negative ions of these compounds. The disappearance of pink color represents the end of hydroxide ions and carbonate ions. And the reactions are: this means the solution now has only bicarbonate ions left. The color has gone. Note down the reading from the burette scale. Okay, now add 2-3 drops of methyl orange into this solution. And titrate the solution against HCl until bright red color is visible. So let's see what's happening inside. As we know, the solution contains only bicarbonate ions. The appearance of bright red color remarks the end of these ions, and this is represented by the following reaction. The bright red color has appeared and this marks the end of titration. So, note the weighting. Wash off the flask as we are going to repeat the process for concordant values. As the HCl was consumed due to the titration, we'll fill the burette up to 0 marking. Well, this is not necessary, but doing this makes the readings easy to observe. After filling the burette, always remove the funnel as some droplets stay adhered in between the funnel and burette surface, and these slip down and disturb the level of the titrant in the burette. Measure 20 ml of sample water. And pour it into the flask. Add 2-3 drops of phenolphthalein indicator and put the flask below the burette and open the stopcock. Titrate the solution with constantly shaking the flask. While shaking, keep an eye on the burette scale. The color has started to disappear. We are approaching the end point of this titration. The color has completely disappeared. Note the weighting. Add 2-3 drops of methyl orange indicator and titrate until the bright red color appears. The color change is clearly visible. Note the weighting from the burette scale. The experiment is over now. Cheers. So as we have the values now, we can calculate the quantity of constituents causing alkalinity in the given water sample. The procedure to calculation is available in the PDF linked in the description. Thanks for giving us your precious time.